Welcome to Caltex Academy. Today we are looking at simultaneous equations, and the method we will be dealing with is Matrix Adjoint Method. We have Matrix method called Cramer's law. We shall look at that later. Today we are looking at Matrix Adjoint Method. And how does this method work? If your corresponding elements are the same, like here we have x and x, y and y, or you can also start with y and ends with x. And then after that we will extract the coefficient of the unknown to make a matrix. And then we shall also have a matrix of the unknown and then the matrix of the constant, and we get the adjoint or the matrix we have formed from the coefficients, and we multiply the matrix adjoint with our matrix equation. Then from there we'll simplify down using matrix multiplication. Now here the first thing we need to do is to rearrange equation number 2 such that we have the first equation is 3x minus y equals 18. Then the second equation becomes x plus 2y equals negative 1. And out of this one, let's extract matrix coefficient of this unknown. So the first element is the coefficient of x, and that is 3. Then here we have 1. Then we have here negative 1. Then here we have positive 2. Now the next one should be the unknown itself. So we're starting with the first letter, that is x, followed in by y. And then this will be equals to the matrix of the constant. So we have here 18 and negative 1. So let's look for the adjoint for this. Adjoint of matrix 3, negative 1, and then 1 and positive 2 is, now for us to get the matrix adjoint, we interchange the numbers in the leading diagonal. This one is leading diagonal, and then we have the non-leading diagonal. Or somebody can call this one as major diagonal and then minor diagonal. So let's start with the leading diagonal. Here we interchange the elements, so we have here 2, and then we will have here 3. And then for the non-leading diagonals, we interchange their signs. So wherever you get negative, we'll send there to be positive, just like this one will go to positive, then the other element will go to negative 1. So this is the adjoint of this matrix. Now let's pre-multiply this equation, this matrix equation, by the adjoint. You can say pre-multiply. By the adjoint. So here our adjoint is 2, 1, then negative 1 and 3. So we're multiplying this one with the left hand side of this matrix equation with elements of 3, negative 1, then 1 and 2. Again we multiply with our constant, sorry, with our variables, that is x and 1 equals to, so we also multiply this one with our adjoint, which is 2, 1, negative 1 and 3, by the constant matrix, and that is 18 and negative 1. So let's perform this multiplication. So we multiply row by column and we add the results together. So in the first one, we'll have 2 times 3, we have 6. Then 1 times 1 is 1 and we add the results together. Now let's move to the next element. 2 times negative 1, we get negative 2. Then 1 times 2, we get positive 2. So let's come to the down one here. The first element from our second row, it's negative 1 times 3, we get negative 3. And then 3 times 1, get positive 3. Then lastly, negative 1 times negative 1, get positive 1, plus 3 times 2, we get 6 here. Then we close this bracket up, and then we come with our unknown variables here with this matrix. So we move to the right hand side. 2 times 18, that is 36, plus 1 times negative 1, it becomes negative also 1, so let us have a negative 1. Then negative 1 times 18, we get negative 18, and 3 times negative 1, we get negative 3. So we close up this bracket and we simplify what is there in the brackets of these matrices. So this one simplifies to 7, here it goes to 0, here also vanishes to 0, and here we have 7. Always the leading diagonals should have some number and non-leading diagonals goes to 0 if you perform this type of operations on matrices. So let's also simplify the right hand side. The first element becomes 35. Then here this one goes to negative 21. So let's multiply lastly here also. First row by this only column here, and then you add the results together, where we have 7 times x, we get 7x, plus 0 times y, we get 0, and then 0 times x, we get 0, 7 times y, we get 7y. Equals the next 35 and negative 21 as the constant matrix from the right hand side. Now because this 0 will just ignore it, plus this one will be the same. Now let's move to the next board and simplify this one here. So the next part will be, we had 7x and then 7y, so it will be equivalent to 35 and negative 21. So let's equate the corresponding element. Equating the corresponding elements. So 7x corresponds to 35. Then we have here 7x equals 35. Now we divide both sides by 7 to get our value of x. Then our 7 cancelled here, and then this one will result into 5. Also, the next element here is 7y, should correspond to negative 21. Again, dividing both sides by coefficient 7 to get the value for y. We'll have from the right hand side negative 21 divided by 7, and our y value will just be negative 3. So these are the solutions to this number. If you wish to check whether the answers are correct, you can do so by substituting to one of the equations, either equation 1 or equation 2. Let's check equation 1. Sorry, equation 2. That says 2y plus x equals to negative 1. Then consider left hand side, which is 2y plus x. Then y value is negative 3. So multiply by 2 plus x value, that is 5. So 3 times 2, 6, but of course it's negative, plus 5. We realize that we have negative 1, which is equivalent to our right hand side of this equation, and for sure it is true. So our answers here are valid. So up to this time, please, if you have not subscribed to the channel, do so, and then give this video a thumbs up to push it to many audience. Now let's proceed to question B, and you should also prepare to have some checkpoint at the end of this video. In part B of this question, we have already the equations arranged. So the only thing we have to do is to form our matrix equation, where we extract the coefficient. So here we have 3 and 5, then 2, negative 3. And then we'll select the first letter, and that is x. Then second letter, that is y. And we equate to the constant matrix, that is 7 and 37. So let's write the matrix adjoint for this matrix here. As before, we interchange the elements from the leading diagonal, and then we interchange the sign of the elements in the non-leading diagonal. So it was positive here, it has just turned into negative 2. So positive 5 will turn to negative 5, and that is the adjoint of this matrix. So let's multiply by the matrix itself. So we have 3, 5, 2, negative 3. And then our unknowns, that is x and y. And then equals to, we also multiply by the adjoint matrix, that is negative 3 and negative 5, negative 2 and positive 3, by the matrix constant here. You see 7 and 37 as the elements of the constant. Now we can perform our multiplication for this matrix. Negative 3 times 3, we get negative 9. And then negative 2 times 5, we get negative 10. And then we move on. Negative 3 times 2, we get negative 6. And then negative 2 times negative 3, we get positive 6. So negative 5 times 3, we get negative 15. And 3 times 5, we get positive 15. And then we move on. Negative 5 times positive 2 with negative 10. Then negative 3 times positive 3 is negative 9. So we close up this bracket and copy our x and y as the elements. So we do the same here, row by column, and add the results together. Negative 3 and 7 will make negative 21. And then negative 2 and 37 we get negative 74. Then negative 5 times positive 7 we get negative 35. And then 3 times 37 will get us 111, and that is positive. So 111 is the result. So let's simplify this again, then we can make it up here. The first element here simplifies to 19 negative, so we have negative 19. And then the second element goes to 0, this one also 0, and we have here negative 19. As before, elements in non-leading diagonals will vanish to 0, and then elements in the leading diagonals will go to a certain number, and the numbers will be the same exactly. So we have the same element, negative 19, negative 19. Now we have here x and y, and then we multiply it by our element here, and we equate it to these results. So when we simplify this, we get negative 95. Then this one simplifies to positive 76. Now when we multiply this one, simply it is just going to be negative 19x, and then negative 19y. So we don't waste the time, we just write there negative 19x as the first element, and then negative 19y as the second element. This is equivalent to negative 95 and positive 76. So equating the corresponding element, therefore we have negative 19x will be equals to negative 95. Dividing both sides by negative 19, have negative 95 divided by negative 19. Our x value will just be 5 also. Then we do the same to the next number here, that is the y in the next row, or maybe we can also squeeze here. So we have negative 19, y equals to 76. When we divide this here by negative 19, we realize that y would be equivalent to 76 divided by 19 is negative 4. Because positive divided by negative is negative. Now these are the values for x, as x is equals to 5, the value for y would be negative 4. So let's move on to the last part, and that is the check-up point question. So please try out and share your answer in the comment section. Now in this check-up point, it says solve the pair of equations using matrix adjoint method. And the first equation is 4x minus 3y plus 1 equals to 0. The second equation is 2y plus x equals to 8. So please take your time, work out this number, make sure you need to arrange this equation such that the elements are corresponding, like 4x and y, and then share your answer in the comment section. Want to check who's going to get the answer right. So without wasting time, please let us meet again in the next video, where we shall also look at more of these questions worked using other various methods like Cramer's rule. See you there. Ciao.